Today, we're talking about RAG failure patterns. When RAG systems fail, sometimes people think that it's a problem with the model itself, or maybe an issue with the prompt, and they try to fix it with some prompt engineering. But the truth is that in many cases, RAG systems fail due to bad storage of your information and poor retrieval of that information out of the database. So the system either has the wrong information or it's retrieving the wrong information. That said, in this video, we're going to talk about some of the core RAG failure patterns. You'll learn more about how and why retrieval breaks, how to recognize those failures in your own systems, some of the high-level fixes for these problems, and ultimately how to build more reliable production-ready RAG systems. So very quickly, let's just review what a RAG system looks like. Here, let's start towards the bottom of the diagram where it says documents. Typically with a RAG system, we take some documents, things like business documents that might mean contracts, standard operating procedures, maybe emails, messages, things like that. We take those documents, we split them up into pieces, and we store them in a vector database. Now, we'll talk in other videos about exactly how that's done technically, but that's the kind of high-level overview of the document processing. Then at runtime, we have a user that can be a human user or a technology system. The user generates some sort of prompt or query. That query gets embedded in a way that it becomes readable by our RAG system. The system takes the embedded query and then finds relevant or similar context, meaning similar chunks from our documents that have been stored, trying to find things that are similar to the incoming query and pulls them out of the vector database. That information is then passed on to the process, and those relevant chunks are added to the original query. In other words, the query is augmented with that additional context, and that collective new context is passed on to the large language model, and the large language model generates an output. Typically, this is a better output than an LLM would have generated just for the query all by itself. By enhancing the query with some of that additional context, we give the large language model more information about the nature of the problem, the nature of the task, and how to generate a good answer or solution. Having said that, even though RAG does help AI systems typically generate much better answers, they can and do fail. So here we're going to jump into 4 of the major RAG failure patterns. Failure pattern number 1, irrelevant retrieval. So in that step where we are taking the incoming query and searching for relevant documents, the system can sometimes find things that are irrelevant. Part of the issue here is that the methods that we use to search for and retrieve quote unquote relevant information, those processes are imperfect. Typically, we're using things like cosine similarity and certain mathematical functions. And due to the nature of embeddings, that process is supposed to pull back information that is semantically similar. So it's supposed to pull back information that is similar in meaning to the query. You have the query, and then it's supposed to pull back information that's very, very close in meaning to that query. But that process doesn't always work perfectly. There can be a variety of reasons for that. Sometimes a retrieved chunk maybe shares a couple of keywords that were in the query, but even though it shares keywords, it's not really relevant to the query or relevant to generating a good answer. There's also instances where maybe our embedding model might be off. The nature of your embedding can affect the nature of retrieval. If you use a bad embedding scheme or embedding model, then you go to retrieve information from your vector database, it can actually work poorly. There's also something called the threshold, meaning if you take all of the retrieved context in rank order from best to worst, you still need to have some sort of cutoff point. So in order to do that, we have something that's literally called a threshold. And the question is, where should that threshold go? Should it be a high threshold or a low threshold? And that's going to impact the nature of the information that's ultimately retrieved. If you have a very low threshold, your system might actually retrieve too much information, and some of that just might be irrelevant. So how do you fix this? Typically, you're going to look at a couple of things. You might try a different embedding model or a different embedding scheme. You might have stricter filtering on the retrieved context, meaning you might take the threshold, and if you had a very loose threshold, you might increase that threshold so that it is much stricter about the information that it ultimately retrieves and passes forward. There are other processes as well, like query transformation and query rewriting, that essentially rewrite the original query that can help with your retrieval step, help it find answers that are ultimately more relevant to solving the problem or answering the question. And there are some other things that you can do, like re-ranking and checking your results, such that after the information is retrieved, then you use some other procedures to take a look at the retrieved context and check and double check to make sure that it is relevant to the problem that you're solving. All of those things have pros and cons. They have costs associated with them in terms of time and money and token spend, but those things can improve the performance of your RAG system if your RAG system is retrieving a relevant context. By the way, if you want to understand if your business is ready to use and implement AI to maximum effect, then take our AI readiness assessment. You can find the link in the description below. Click on the link. It's only about 15 questions. It takes less than 4 minutes. It's free, and it's going to give you a clear picture on how ready you and your business are to use AI to generate business value. So click on the link in the description below and take our free AI readiness assessment. Next, we have the problem of missing context. This is when your system fails to retrieve the right context or a sufficient amount of context to generate good answers. So when this happens, it often kind of looks like a model that's struggling to perform, a model that doesn't have a RAG system at all. So if there's missing context, sometimes a model will hallucinate a little bit more, or it will struggle to provide really good answers. Or similarly, the model or system might produce answers that look kind of right, but a little bit incomplete. Now, there are ways of technically diagnosing missing context. We'll talk about that in a separate video. So how do you fix this? First, you can increase top K. Essentially, you're going to accept more of the retrieved context. If K is the total number of chunks that are retrieved, you're going to increase K and retrieve a larger number of chunks. This is sort of like loosening up the threshold, so the system is less strict. You also might need to improve the coverage of your documents, meaning you might need to get more original documents to ingest into your vector database prior to runtime. So in some cases, the fact that there is missing context in your RAG system means that it wasn't in the vector database to begin with. So this isn't always just a retrieval problem. It might be a document availability and ingestion and storage problem. So if you're missing context, you might need to go and find other documents. Next, we have the problem of bad chunks. So let me explain what this means. Remember, when we have a RAG system, we're taking documents, we are processing those, and typically splitting the documents into smaller pieces that we call chunks. Then we take those chunks, we embed them, we transform them into a numeric form, and then we store them in a vector database. Now, the problem that I'm talking about here is when we take the larger document and split it into pieces, there are a variety of different ways that we can do that. Do we use big pieces or small pieces? How big should they be? And no matter what their size is, should they be strictly separate from each other, or should they have a little bit of overlap? There's also a variety of different ways of chunking data, chunking at paragraph breaks or page breaks, chunking at HTML tags. There's a variety of different ways of doing this, and how you chunk your documents down into smaller pieces can impact the performance of your RAG system. Maybe a little bit more specifically, remember what we're trying to do is we're trying to take big documents and find pieces of those documents in a way such that they capture a sort of idea that we can take and store in a vector database that can be then later retrieved and used to augment a query. But let's say we have a long document and there's a single idea that's maybe spread across multiple different paragraphs. If we maybe split those paragraphs apart, you might have one important piece of that idea in one paragraph in one chunk that gets stored as a separate chunk, and then a different paragraph that gets stored in a different chunk. And because they're being separated, sometimes they won't be retrieved together at runtime or at retrieval time. So if you chunk your information incorrectly and you're taking things that are related to each other and splitting them apart, that can sometimes cause problems with your RAG system. Said differently, if important ideas in your documents are too fragmented, that can cause problems. So how do you fix this? Essentially, there's a couple of different ways. You can adjust the size of your chunks. You might need to experiment with this a little bit and try several different chunk sizes, rerun your RAG system and run your RAG system with some test cases to see how your RAG system performs with various chunk sizes. You can also add some overlap between chunks. Remember what I was talking about a minute ago? If you have some sort of idea or topic that's split over multiple paragraphs, and if those are split into separate chunks, one thing that you can do is you can actually add a little bit of overlap between the chunks so that chunk 1 goes through multiple paragraphs and chunk 2 actually covers some of the same material. If there's a little bit of overlap, you can sometimes fix that problem. Ultimately, though, what we're trying to do is we're trying to keep semantically related information, or we're trying to keep topics in a document relatively connected and kept together inside of our chunks. So you need to think very carefully about your chunking strategy when you are ingesting and processing your documents. Finally, there's a problem that we sometimes call the lost in the middle problem. In this problem, the correct information is retrieved, but it's buried inside of a lot of other context. To explain this a little bit further, let me give you a quick example. Let's say you have a RAG system and it retrieves a lot of context, not just a couple of chunks, but a lot of information, maybe too much. What tends to happen in these circumstances is large language models tend to pay closer attention to the information at the very beginning of the context and the information at the very end of the context, but they're often more likely to forget or miss the information that's in the middle of the context. Interestingly enough, human beings do something very similar when you take a look at how human beings perform on memory tests, but I'll save that explanation for another time. Essentially, though, you can have the right information, but if it's buried inside of a large amount of context, especially if it's in the middle, it can get lost and the system won't be able to find it properly. And your large language model might miss or ignore that information as it's generating an answer. This can reduce the quality of your generated outputs. So how do we fix this? There's a couple of different ways. Number one, you can decrease the number of chunks that are retrieved. So essentially, this is like making your threshold a little bit higher. You can also use some ranking processes to rank the retrieved context such that the best, most relevant answers appear at the top of the context, which is going to be easier for a large language model to pay attention to. Ultimately, in order to fix this, we are trying to keep our context narrower, more relevant, and more focused. Ultimately, if you want to build RAG systems that enhance your broader AI systems, you need to pay attention to these failure modes. You need to make sure that you are ingesting the right documents, that you are retrieving the right information, but also while avoiding retrieving too much information. Ultimately, though, if you can get this right, RAG can be critical for grounding AI systems in your data and helping your AI systems generate better answers that solve your business problems. But even if you can build great RAG systems, RAG is only one piece in a larger AI system. That's why you should understand broader AI architecture. So in this next video, I'm going to cover the main pieces of a typical AI system. That includes RAG, but it includes other things like orchestration, tool use, guardrails, and more. You can check it out here. AI Architecture Explained.